No, we can't. All right, let's go, Josh. Let's get inside. Let's get our packets out. So yesterday, I don't know what was up with you guys, but you guys seem pretty dead. You guys are pretty out of it. So I don't know how much of the lesson you retained yesterday. We're going to do a little review problem. I don't know what happened in first period yesterday. I don't want to know.
I thought yesterday was off.
Yeah, yesterday was off. So I have to make sure that you know what we did yesterday because it seems like you guys weren't paying attention. So this is not in your note package. This is just a review. So we're given a chart. We know how to find the slope and y-intercept of a graph. That's very easy. You just count up and over, and then you find out where it crosses the y-axis. So it's very easy to find slope, and it's very easy to find the y-intercept. We also know how to find slope and y-intercept when we're given an equation, right? The y-intercept is 3 and the slope is 4. Right? Now, what we learned yesterday is how do we find slope and y-intercept when we're given a table? All right, so how do we find slope? We have to use the what? The slope formula, which is?
y2 minus y1 over x2 minus x1.
Yep, y2 minus y1 over x2 minus x1. And then, how do I determine my 2 points? I have a table. I have 3 points. Does it matter which 2 I choose? No, it doesn't. So I'm just going to use, I'm going to go ahead and use 2, 9, and 4, 15. And we can make either one of them our 2s and either one of them are 1. So I'm going to make these my 2s. This is my x and y2. These are my x and y 1s. And then I can just go ahead and plug it into my formula. So I would have 15 minus y. And I would have 4 minus 2. So what would my slope be for this table? It's not an example. So what's my slope here? 6 over 2, which equals 3. Right? So that's how you find your slope from a table. All right, now, this is the tricky part. How do you find the y-intercept of a table? We can't count down and we can't count up in this example.
Oh, wait, I see.
What's up? Over there. I think so.
Y-intercept is 3.
Find a 0.
So, we got to find out. Yes, Lillian is right. If you have x equals 0, then you can go ahead and whatever the corresponding y value is going to be your y-intercept. But do we have y equals something at x equals 0? Like, yeah, we don't have an x equals 0. This is not on our chart. Let me write it in red. So we don't have an x equals 0. So we have to use a little bit of algebra. I have to go take the slope-intercept form equation of a line. What is my equation of a line? It's y equals? Nope. What is the mx plus b? And we have to plug in some values. Well, all of these right here in my table, this is an xy, that's xy, that's xy. We have to plug in one of these pairs. We can choose any of these pairs, but one of them. Which one's going to be the easiest?
2, 9.
The 2, 9, right? So what is y going to equal? Y is not 2.
3.
Y is, dude. I'm going to take the point 2, 9. Where did I get that point? I got it from the chart. I know that it's xy, so x goes first. Y, so what is my y value? 9 equals, what's m? 3. What's x? 2 plus b, because we don't know b. Now we can solve, right? Let's do it. 9 equals 6 plus b. And then this is a math fact. What number plus 6 equals 9? 3. So the y-intercept equals 3. All right, so that's what we learned yesterday. You do have to know that for your test. It's easy to find slope because you just plug it into your little slope formula that you guys have been doing for a while, right? But y-intercept, you have to know to use this equation. I'm going to give you some examples that you can't count down. Yes? I promise you.
Maybe.
Okay,
I'm so gonna.
so let's go to example 1. You're going to have 2 graphs that kind of look like this. I'm just going to go like this, and then you're going to have another graph that looks like this.
This one is just obvious.
Yummy, yummy.
So example 1 is really simple. Example 1 says which graph is linear, which one is nonlinear. So we're going to have the one on the left, and we're going to have one on the right. Which one is linear? Baron? The left or the right? The left. This is linear. And then the other one on the right is non-linear. And how do we know that? It's pretty simple. Because it's not straight. A non-linear line is not straight. Now, are they both functions? Yeah, they're both functions because there's not a point where they're vertical. They all pass the vertical line test. It doesn't bend over on itself. It doesn't like double back on itself. So the answer right here is the left one is linear and the right one is nonlinear. Why? Because one's a straight line and one's not a straight line. So super simple. Right? We're able to look at a graph and be like, oh, okay, that's linear. All right, so example 2, we're going to have all these equations in the box. So we have to be able to look at equations and figure out which ones are linear and which ones are nonlinear. All right, so what is the equation of a straight line? Y equals mx plus b. If a line is in this orientation, if it follows this format, it is linear. Because if you have a slope, you have a straight line. Right? Slope is for straight lines only. So let's go ahead and look at all these expressions, right? You have a big table in a box. Let's just go right to left, right? So the first one is y equals negative 2x minus 5. Just by looking at the equation, is it linear or nonlinear? It is linear. So this one is check mark green. This is linear. All right, your next one over, right? Because this one is in the mx. Technically, it's plus a negative b, right? So this is y equals mx plus b. Let's do the other one. You have another one where you have y equals x squared plus x plus 3. Now, is this linear? Why not?
Because
It doesn't follow. So let's check it out. We have y, we have x, and we have b. But what is this x squared right here? It's not m, right? It's not m. A little trick, if you ever see an exponent that is higher than 1, so if you see 2 and up, it is not linear, right? So this is non-linear because you have an exponent. In y equals mx plus b, there is no exponent. Technically, it's an exponent of 1. You don't have to write that. So, if you ever see an exponent, even though it looks very similar to y equals mx plus b, it is not linear. Let's do the next one.
What if it's like the exponent's x?
We'll find out. Next one, Randy, that is what you're seeing. So you have y equals 4x plus 5. Now, again, this is very similar to y equals mx plus b. You have y equals mx plus b. Right? The 4 would technically be considered an m, but what is unique about the letter x in this problem?
it's the power.
It's to the power of x. Again, if I have an exponent, is it linear? No, no matter what. If I have an exponent y, if I have an exponent x, if I have an exponent, if I have any exponent, a number or letter, it is not linear because you have an exponent. In the original y equals mx plus b, there is no exponent. So that one is not linear because it has an exponent. All right, now this one's a little tricky, okay? This one is going to require some algebra. Not necessarily algebra, but it's going to be y equals negative x over 4 minus 9 over 5. Now, is b, right? Is this allowed to be a fraction?
No.
Can b be a fraction? Yeah, you can cross the y-intercept at a fraction. So we have a b. It is okay if b is a fraction. Now, is it okay for x to be a division problem? Well, let's find out. Could I rewrite this? Let's pay attention. Technically, this is 1x, correct? It's technically 1x, yes? So couldn't I rewrite this as y equals negative 1/4 x minus 9 over 5? Yes, I can rewrite that. It's the same thing. Dividing by 4 is the same thing as multiplying by 1/4. Is m allowed to be a fraction? Yeah, your slope can be a fraction. You would just go up 1 over 4, up 1 over 4, or down 1 over 4. Down. So m m is allowed to be a fraction. And does x have an exponent, or is it just x? It's just x. So is this linear? This is linear. So this is linear, right? So x is allowed to be divided by something. That is still linear. You can still divide x. So that's linear. Do you guys all have the first four?
Yeah.
All right, so let's do the bottom four now. Remember, we still want to use the y equals mx plus b to determine if it's a line. All right, let's check out this equation. We have y equals 8 times the square root of x minus 3. I have y, I have an m, I kind of have an x, and I have a b. It's technically plus a negative b, right? So is this very similar to my equation? It's incredibly similar, but am I allowed to have a square root x? No. So here is mathematically why I'm not able to do that. Lillian, close the Chromebook when it's done. Do that. Okay, so when you have a square root of a number, it is actually the same thing as saying to the 1/2. A square root is a fractional exponent. Are we allowed to have exponents that are outside of 1? No, this is 1/2. Right? So you are not allowed to have a square root. That is not allowed if you want a linear expression. So this is a curved line. It is nonlinear. You can still graph it. It'll look something like this. Actually, it'll look something like this. It would still graph as a line, but it would not pass the vertical line test. It would not be a function, and it's not linear. So, what are the two things that we can't have? We can't have exponents and we can't have square roots of x, right? So you can't have a square root, can't have an exponent. Let's do the next one. All right, this one's pretty simple. We got y equals 10x. Does this follow my y equals mx plus b? Yes, what is b? B is technically 0, right? So I have a slope, I have an x, I have an y, I have a b. There are no exponents, which is good. So this all checks out. This equation right here is a linear equation. That is linear. Pretty simple. That's the easiest one on the board. All right, next one. Next one, we have y equals -7 plus 2x. Let's go with Josh. Is this linear? Is this nonlinear? And tell me why. Yeah, does that follow my linear equation? So is this graph going to be a straight line? Why? Well, what am I not allowed to have? Like if it's going to curve at all, the line, it can't have two things. One, it can't be a square root, right? And it also can't have a what? Not a number next to it, but a number as an exponent, right? So if I take a look at this x, it doesn't have an exponent, and it doesn't have a square root. So right off the bat, I'm thinking, okay, this may be linear, but it's not necessarily in that perfect y equals mx plus b. Well, is there a math property that allows me to switch these?
Yes.
The commutative property allows you to switch addition and actually technically subtraction problems. So we can actually switch it to y equals 2x minus 7 using the commutative property of addition. Now, is it in my perfect y equals mx plus b? Yeah, it is. So this is a linear equation. This is linear. All you had to do was switch them around.
I guess.
So what you guys need to realize is, one, it can't have an exponent and it can't have a square root. And if it doesn't have one of those, it is probably going to be linear. Next one, our last one. We have y equals 6 over x plus 2. Now, this is different. In the other example that you guys had, I'm going to rewrite it up here. In the other example that we had, it was y equals x over 4, technically negative, minus 9 over 5. All right, so this right here up top, this was linear because you could rewrite it as 1 over 4 times the letter x. Now, is it okay for x to be in the denominator? Right, so if I back up, my x up here is a numerator. Can x be a denominator? And the answer is no. Non-linear when x is a denominator. You can't have it as a denominator. I believe that if you were to write this out, it would be 6 times x to the negative 1. And you can't have an exponent outside of that. So this is nonlinear. All right, so there are three things. There are three things that make x nonlinear. What are they? What are the three no-nos?
Oh, the exponent.
X cannot have an exponent, right? So x cannot have an exponent. X cannot have a, and then x cannot be in the, there you go. Right, so those are the three things that you cannot have in order for it to be a straight line. Can you still graph x squared? Yeah, if you were to graph x squared, it would look something like this. It looks pretty cool. If you were to graph x to the power of 3, it would look something like this. It's pretty cool, but it's not a straight line. If you were to graph the square root of x, you would get something that looks like this. Still not a straight line. And I believe if you were to graph something like this, you would get something that looks like this. Not straight lines. Now, let's go to example 3. Here is the tricky part, okay? So, now, you guys know how to determine if a function is linear by looking at its equation, right? You just know it can't have an exponent, it can't be a square root, and it can't be in the denominator, right? It can't be any of those things. Now, looking at a chart, can we determine if something is linear? Here's how we're going to do that. So, there's a very easy way to do this. And you guys have a picture, right? It should say, is this a linear function? All right, so there's a very easy way to do it that only works about 10% of the time. So if I have this, I think the first one looks like this, 1, 2, 3, 4, and then it's 12, 7, 4, 3. What you have here is you have a pattern. X is increasing by how much? Plus 1. And then y is decreasing by, well, this is minus 5, this is minus 3, and this is minus 1. Are there patterns on both sides?
No.
Not really. You're subtracting by 5, you're subtracting by 3, and you're subtracting by 1, whereas on the other side, you're adding 1 the entire time. So this is nonlinear.
Because you're taking away 2 from how you subtract everything.
You want it to be the same. You want it to be constant, right? So non-linear. No, non-linear. All right, now the next one, your next one, you have a pattern where you are adding the same number on both sides, right? You have 1, 2, 3, 4. So I know the pattern on this side is plus 1. And then you have 0, 2, 4, 6. The pattern on this side is plus 2. If you have a pattern on both sides, it is linear. If you have a pattern on both sides, it is linear. This right here only works about half the time. Because if you have a pattern on both sides, it's linear. If you have a pattern on x, if you have a pattern for x, but don't have a pattern for y, it is nonlinear. Now, what happens if you don't have a pattern on either side? Depends. The answer is it depends, right? So I want to kind of teach you this trick. like I said, if you have a pattern for x, but you do not have a pattern for y, let me do it in different colors. So if x has a pattern, but y does not have a pattern, it's nonlinear. If they both have patterns, it's linear. If they both do not have patterns, it depends. It can be both. So let's work on that right here. Example 3. You have this chart right here, and just by looking at the chart, does x have a pattern? Sorry, example 4. Example 4. Example 4. Is there a pattern to the x column? What is it? You're adding plus 3. And then the y, is there a pattern? Yeah, you're adding 2, right? 8 plus 2 is 10, plus 2 is 12. So is this linear? So it's linear because x and y have rates, right? You're adding by a rate. There is a constant rate. I'm actually going to have a constant rate of change. You are always adding 3, and you're always adding 2.
X and Y have rights instead of
Oh, rates.
X and Y rights. Yeah.
So example 4 was an example of something that was really easy. All right? Let's go to example 5.
What if it's like the left side is a pattern but the right is not? Then
It's
it's
a raw.
No, it's not. Yeah, it's not a linear
Oh,
function.
sorry, I mean the
It's
other.
a raw.
No, you're right, it's not.
Wham, wham, wham.
Do it yourself.
It's a raw.
It's literally one word. Oh yeah.
What if you buy
messed up.
When it stops raining.
Can I just buy them right now? Or like half?
Yeah, you could eventually, like at science. I could. Okay. So let's go back to example 5. For example 5, we have this chart. We have 0, 6. So first thing right off the bat, is there a pattern? For x. Is there a pattern for x? So Emmy, example 5, is there a pattern for x?
Yes.
Emmy.
Well, yes, there is.
What are you adding by each time? Adding by 1, right? So there is a pattern for x. However, is there a pattern for y? No, you're adding by 6, and then you're adding by 7. So if x has a pattern but y doesn't have a pattern, is it linear? It is not. It is not linear. It's not linear. Right? And the reason is only x has a constant rate of change. So it's constantly changing by 1. However, y does not change constantly like that. Now, example 6. Right? Yeah.
You said it's not if y has a pattern and x doesn't, but is it possible? Because I feel like there's definitely.
Let me think about it after example 6, and then we'll get back. I'll get back to you. Okay. Example 6, this is that tricky one where we got to identify patterns. You have x, y, right? So you're going to have -7, then you have +13, 19, then you have 18, -2, 8. We don't have patterns here because you're adding by 20, and then you're adding by 6. And then you are subtracting by 20, and then you're adding by, oh, this is negative. Whoops, -8. This is -8. And then you are subtracting by 6. So do we see how there is no constant rate of change for x and y? Do we see how there's a constant? Right now, there is a pattern, right? There is a pattern. You're taking away 20 and adding 20, and then you're taking away 6 and adding 6, but that is kind of irrelevant right now. So x does not have a pattern, and y does not have a pattern. When they both don't have a pattern, there is no cheat sheet. You have to do this, and you have to do the slope formula twice. You have to find the slope using these two, and then you're going to have to find the slope using these 2 points. All right, so I want you to pay attention. We got to find the slope using the top 2 points, and then we're going to have to use the slope using the bottom 2 points, right? So it's going to be -2 minus 18 over 13 minus 7. And then you're going to have -8 minus -2 over 19 minus 13, right? So, yeah, exactly. So you have to use the slope formula twice with 2 different points. Doesn't matter which 2 points, but it has to be 2 different points. So -2 minus 18 is negative 2 minus 18,
20.
-20. 13 minus 7 is 6. All right, on the bottom. -8 minus -2 is technically -8 plus +2, which is -6. 19 minus -13 is 6. It's positive. So this equals -1, and this equals, if you reduced it, it would be -10/3. Do they have the same slope? No. If they don't have the same slope, it is non-linear. We're going to do more examples of this tomorrow. You don't have any homework for today.